In lesson 7, we're going to talk about how to combine different plots together, like multifaceting and inset plots. This is lesson 7, and we're going to open up R, and here is our multifaceted figures, our script. As always, we need to make sure the working directory is this folder that has the lessons inside of it, and we're good. We're going to read in the same data that we used before. I'm just going to reset the theme so that the text size is small again, because we're going to have a lot of plots on one page now. This is the same data we were dealing with before. That is the variant data with types like insertions, deletions, expansions, and contractions. We're going to do the same filtering and polishing that we've done before. And then this plot should look familiar. We encountered this in lesson 6, and this is a geome density plot where the different distributions here, one for each variant type, are overlapping each other, so we gave them an alpha of 0.5 so that we can at least see through them, but it still looks like kind of a mess. And so last time I showed you a sneak peek that looks like this, where we can take them and make them different rows. So the way this works is you use facet grid. So this is the only difference. You can just add it to any plot you have, and we facet grid it by type. So we can do it in this direction, where it's going to split up so that each row becomes a different type. And you can also do it this other way around. So it has, essentially here, it is row, squiggle, and then column. And if you don't want there to be multiple plots for each column, you just put a dot to signify that you don't want anything there. And so if we do it the other way around, we do row is nothing now. So before we had rows but no columns. Now we have no rows, but we have type as the column. So let's see what that looks like. So it doesn't look very great, but you can see what it does here. So each column now in the plot becomes a different variant. Again, these are in the same order that we wanted them to be when we set the levels up here. So levels equals insertion, deletion, expansion, contraction. That's the same order they're in the legend and when you start doing the multifaceting. So facet grid type squiggly period or dot, that's going to make it like this, where you have rows, and then the other one is where you have them as columns. So think facet grid row, squiggly, column, which is a lot like what we do when we index them, like row, comma, column, to take part of the data set away. So it's always, for multifaceting, rows, squiggly, columns. Or it's a tilde or something, but we'll call it squiggly because it's cuter. So we can also facet on multiple things, so you don't have to put a dot every time. You can also do other things. Like for instance here we can take chrome squiggly type, and that's going to make the rows into chromosomes and the columns into types. Usually it takes a little while because now it has to actually draw something like 92 plots. And here it goes. We have 4 columns because those are the types, and we have these 23 different rows. That's the chromosomes. And so that's a lot of plots to make all at the same time. So that's why it takes a second to run when you do these. So that's one way to do it. This looks pretty nice. You can see, for instance here, chromosome 19 looks like it has more variants on the smaller side for the deletions, but it doesn't look that different for the other types. So you can try to see how the distributions differ depending on what chromosome you're on and what type you're looking at. So that's pretty cool. And we can also do it the other way around here, where the rows become types and then the columns become chromosomes, like that. So that'll take a second to show up again. And there we go. So now the columns are chromosomes and the rows are types. And so you can kind of play with this, switch them around, and see how best to explore your data and how to show these relationships. In this case, I don't think this one looks very good because you don't get as much of a view of all the chromosomes as before, and the distributions aren't as comparable to each other. So in this case, I like the first one better, where rows are chromosomes and columns are types. So that looks good. That's probably one of the most useful things you can do with multifaceting, is to just get a view of everything that's going on. Another thing we can do is we can do a couple of different types of plots here. So I've shown you the multifaceting and how that works with rows and columns, and having two different variables, one for columns and one for rows, versus having only one, like the type like this, where you only have one of them. So there's a lot of different things you can do here. Here are a few examples. You should be able to understand the code that we have so far. It really matches up with something that we've done in the previous ones. So this is one option here. This is a bar plot. So we're doing the bar plot just like we did the density, with the same x-axis being size, y-axis is count, so it's a histogram. And this one is not as easy to see as those distributions we had before, but there are a lot of different options here, that's the point. We can also do box plots. Here we have a box plot for each chromosome on the rows, and here to make the columns into types would be redundant because they are already types, and then it just looks really funny. I can actually show you what that looks like. So if I make this into type, then it's going to look really dumb. It's either going to look dumb or be redundant. Yeah. So this is kind of dumb, right? It has insertion, deletion, expansion, contraction for each one, but then only one of them actually has data in it. So then it becomes redundant, and there's no need to do that because we already have the types represented in a box plot automatically. And then the same goes for the violin plot here. So the only difference between the one I just showed you here and the violin plot is just that we're drawing a violin plot instead of a box plot. But other than that, it has the chromosomes as rows, and it already shows the distributions of each different type as a different column. Here we're facet gridding, so row is chromosome, column is type. In this case it makes more sense because they're points, so they're not already broken up into different types, except by colors, and so now it's easy to see what's going on here. So that could be kind of cool. And we also have dot plots, just for the heck of it. See what comes out of that. And yeah, look, we have little dots everywhere. Isn't it pretty? Another thing that will probably be a little bit more useful than those dot plots, the best one so far is probably this one. That's one of the more useful ones for this data set. But this is to show you that you can take any of these plots that we had before in the lesson 6 and actually make them into multifaceted plots, so you can view multiple variables at the same time and do all these different comparisons. This one is the best example from this particular data set of what we can do with multifaceting. Now let's talk about inset plots. These are plots where you have something sitting inside something else. So I'm just going to run this and show you what comes out of it. Yeah, we'll just run it, and I'll show you what comes out. It's not this one, this is one of the plots. So instead we want to actually pull this up. So this is the point here. We want to have one plot like this, and then we want one other plot to be inside of it. So in this case we have the full distribution as a histogram on size, and then we're zooming in on part of the x-axis here, so we only have the sizes from 0 up to 500, and that is in the form of an inset plot, and then they kind of share a legend here. So we don't want the legend twice. So I'm going to show you how we can produce this, and notice also it's kind of publication quality format here. We can always change the resolution of it, but the important thing here is we made it our special publication theme that we discussed back in the tweaking everything in lesson 5, where we have the white background, we have the axes but no box around them, And in this case, we're keeping the legend just because the colors are hard to describe, but you can take the legend out too. And it shouldn't make that much of a difference. So this is what we're trying to make. So let's talk about how we make that possible. We have to make the two plots separately. The first thing we do is set the publication style theme by going theme set, and then we do a theme gray plus theme with these different ones. And so I'm going to break some of this out a little bit so you can see what's going on, like that. Yeah, we're just going to cut it at all the commas here so it's easier to see what's happening in the theme. But this is the same stuff that we've done before. Nice. Okay, so now it's like really beautifully broken out. See, the parentheses are even matching up with each other where they're starting and ending. It's beautiful. So we did theme set, theme gray, like the normal gray theme, plus we want the axis lines to be thinner. We want the background to be non-existent, basically be white. And we want the minor grids to be gone. The axis text, we want that to be size 16. And then we want the axis title element text to be size 18. So that's what we have there. And so we can mess a lot with all of this. But yeah, here we go. So let's do the big plot. So we're just going to assign these to variables. So this is one of our plots. We basically make the plot exactly as we would want to do, and we just assign it to the big plot variable so that we can use it again and again if we wanted to. So I'm just going to show what the big plot looks like here. This is it. This is the big plot. Awesome. And then for the smaller plot, I'm going to do it like this. So the small plot is going to look like this on its own. Notice that we made the axis labels disappear. So this is the axis title equals element blank. So instead of being element text, it is now element blank, so there's just nothing there. And that's what we're changing. So that's the only thing we're adding to the normal publication style theme that we made up here, which we set that affects both plots. Here we're just making one little change. And then we're also using our scale y continuous. This was the trick that brings the bars down to actually touching the x-axis where they normally kind of float above it, which looks great when you have a gray background, but when you don't have the gray background anymore, then it just looks really dumb. So this is what the small plot looks like, and it's important that these labels are gone because otherwise they're going to be really redundant on the plot, and you usually don't want that. So now we have to talk about how we can actually put both of these plots onto the same plotting area. And the way we do that is we use a library or package called grid. And if you don't have that installed already, then you can go up to packages, install, type in grid, and it would be in here if it's not already in the base package, which it probably is since it didn't show up. And so you run that library grid, and then we have to make a viewport. So this is something that is in the grid library, so it doesn't exist unless you load in grid like that. And this viewport is going to tell us where we want to put the small plot. So later we put the big plot, then we put the small plot, and we say I want the viewport to be this VP viewport here that I make. So it's like a special object. And this viewport has a width of 0.8. This is between 0 and 1 and kind of describes how big the plot is. So the width is 0.8, the height is 0.7, so this is how much of the plot it would be taking up. And then the x and y positions are the positions where it is located with respect to the bigger plot. So you can basically just mess with these and put the numbers up and down, but these are the numbers that I determined are good for putting this plot in the right position. So when you have different plots, you usually have to tweak these a little bit, and so it's hard to automate this exactly, but when you do get new data in, if you don't change anything else about the plots, they'll still be in the same position, just with new data, and then you just have to run it again, and you don't have to change anything once you've got the inset positioned correctly. So we're going to run this, and that's going to produce that plot that we saw before. Yeah, right here. So the size of the little plot is determined by the width and height of the viewport over here, and then the x and y determine, the x is like how far to the right is it, and the y is how far to the top it is. And that's basically all we have to do. So this is what you could change. You could change the small plot and the large plot, big plot and small plot. You can change what plots they contain in here and try to stick them together, change these values if you have to tweak them a little bit, and that's how you can also make an inset plot if you need that for your next paper or something. So that's it for multifaceting and doing inset plots. And so that's all of lesson 7.